Hello everybody, this is Professor Jason Kim. At this video, we're going to review the arithmetic and pre-algebra, and mainly we're going to go over a review of fractions. Now, to understand the fraction, we have to know some terminologies. So we're going to go over some terminologies as well. The first terminology we need to know is something called rational numbers. Rational number is a number that can be expressed or can be written in fractional format, like a over b. And a and b has to be an integer and b is not equal to 0, because they do not allow to have a denominator as a 0. So that's the rational number, and then they include integers and all the fractions. Like 2 is integer, that's a part of the rational number. Or any other fraction like half, 5/3, 3/1, 24/7, -2/5, -3/1. Those are all rational numbers. So form of a over b, fractional format. Any number that can be written in fractional format, we call that one as rational number. But you have to make sure that a and b are integers and b cannot be equal to 0. Does everybody understand what rational number is? Now, what is a number 1 as a fraction? Number 1 is like a magic number. It can be expressed in fractional form in which the numerator and denominators are same, except when the denominator is 0. So 1 can be expressed as a 3/3. See, numerator and denominator same. And 1 can be interchanged with a 10/10, 5/5, 18/18, and -12/12. So 1 can be changed into rational number as long as their numerator and denominators are same, then it's acceptable. So how to make an equivalent fraction? Equivalent fraction is, in other words, equal in value fraction. So sometimes we interchange with equal value fraction when they represent the equivalent fractions. So equivalent fraction is a technical term for the equal value fractions. To make an equivalent fraction, we use the fundamental principle of fractions. Property of a fundamental fraction principle of fractions are when a equal b, you can multiply any other number top and bottom. As long as it's the same number you're multiplying, they are equal to the regular fraction, providing the number you're multiplying is not 0. So by multiplying numerator and denominator by the same number, the resulting fraction becomes an equivalent fraction. It is the same as multiplying fraction by 1. Now, example, write an equivalent fraction of half. So if you have a half, if you multiply 1 and 1, 1/2. If you multiply 2 and 2, 2/4. If you multiply 3 and 3, same number, 3/6. 4 and 4, 4/8. If you multiply 5 and 5 to the 1/2, it's same as 5/10. If you multiply 1/2 with a 10 and 10, then it ends up with a 10 and 20s. So all this result are equivalent fraction. So 1/2 has an equal value with a 2/4, 3/6, 5/10, and 10/20. They are all equivalent fractions. How about equivalent fraction of 3/4? Okay, if you multiply 1 and 1 on both sides, the numerator and denominator, it becomes 3/4. If you multiply 2 and 2, it will be 6/8, 9/12, 12/16. If you multiply 5 and 5 to 3/4, you got 15/20, 18/24, 30 and 40, 300 and 400. So 3/4, 6/8, 9/12, 12/16, 15/20, 18/24, 21/28, 30, 40, and 300 and 400. They are all equivalent fractions. In other words, they all have equal value. Now write a 3 equivalent fraction for each fractions. I'm going to just do only like one example, one exercise. If you multiply 2/3 times 2 over each, you got 4/6. If I multiply 2/3 with a 3 over each, I got 6/9. If I multiply 2/3 with a 4 over each, 4 in numerator and 4 in denominator, I got 8/12. So 2/3 and 4/6 and 6/9 and 8/12, they are all equivalent fractions. Now, next topic is how to simplify fraction. To simplify the fraction, you have to know another terminology called prime numbers and composite numbers. Prime numbers are the number that factors include only it and one and itself. So examples of the prime number, which is a good idea to memorize, these are the prime numbers, is 2, 3, 5, 7, 11, 13, 17, 19, 23, and all those. Those are the prime numbers because those numbers do not have other factors except one and itself. So for example, like 7. 7 is only divisible by 1 and 7 itself. That's why 7 is prime number. As well as 13. 13 do not have any other factors, any other number that divisible by evenly except 1 and 13. So those are the characteristics of prime numbers. How about composite numbers? Composite number is opposite of prime numbers. Composite number is a number that has a factor other than 1 and itself, like 4, 6, 8, 9, 10, 12, 14. So they are not prime numbers, they are composite number. For example, 6 can be multiplied by 2 and 3. So 6 is divisible by not only 1 and 6, but also you have a factor of 2 and 3. So it composed with other factors. So they call composite numbers. Same thing as a 9. 9 not only have 1 times 9, but also 3 times 3. So 9 has a factor of 3's other than itself and 1. So 9 is composite number. Now, rule for the simplifying fractions. You write the numerator and denominator as a product of prime numbers and cancel out the common factors in the numerator and denominator. Like A times C and B times C, you cancel out the common factors, C's, in the numerator and denominator, if the same numbers are at the numerator and denominator. And then it turns into B over A. We call this is reducing it or simplifying fractions. So now, if you have 6 over 8, 6 over 8 can be written as a 2 times 3 as a 6, and 8 can be written as 2 times 4. And they have a common factor 2 in both numerator and denominator. So 2 is common factor. Then you can reduce top and bottom, 2 and 2. You end up with a 3 over 4. So we call this process as simplifying fractions. So fraction 6 over 8 has been simplified to 3 over 4. And if you can do further, then you do more until you cannot simplify anymore, which means until you don't have any common factors between numerator and denominator. Again, if you have a 25 over 20, 25 can be written as 5 times 5. 20, if you write in prime numbers, is a 4 times 5, but 4 is not a prime number. So 4 can be written as a 2 times 2 as a prime number. So you write as a 2 times 2 times 5. So at that point, you have a common factor 5 on the top and 5 on the bottom. In other words, you have a 5 in a numerator and 5 in a denominator. So they can be canceled out. You end up with only 5, 1 5 on the top, and 2 and 2, which means 2 times 2 is 4. So 25 over 20 can be simplified as 5 over 4. How about 18 divided by 36? You will write the multiple of prime numbers from 18. So 18 is like 2 times 9. 2 is a prime number, but 9 is not. So you break 9 as a 3 times 3. So 18 is 2 times 3 times 3. Now 36 is 2 times 18. And 2 is a prime number, but 18 is composite number. So you can do more. 2 times 9. So 2 is a prime number, but 9 is not a prime number. 9 is a composite number. Again, you can break into 3 and 3. So when you write 36 in terms of a multiple of prime number, it ends up with a 2 times 2 times 3 times 3. We call this as a factor trees. So when you make a factor tree, it helps you to represent the number in multiple of prime number only. So you end up with a 2, 3, 3 on the top, and you end up with a 2, 2, 3, 3 multiples of those in the bottom. So 2 and 2 cancel out. 3 and 3 cancel out. Another 3 and 3 cancel out. On the top, you have nothing left. When there is nothing left, you put 1. On the bottom, 2 left. So you put 2. So 18 over 36 can be simplified as 1/2. Same thing goes with the 12 over 54. When you make a factor tree of 12, every even number has factor of 2. So you start with a 2 as a first prime number. So 12 becomes 2 times 6. Again, it's an even number. It's a 2 times 3. So you end up with 2 and 2 and 3 for 12. Now you can break 54 in multiple of prime number. Again, it's an even number, and every even number has a 2 as a common factor. So 2 is your first prime number. You divide 54 by 2, you end up with 27. Now, 27 is not an even number, so you try with a 3. 27 is 3 times 9, and you can break 9 as a 3 and 3. So 12 consists with a 2 times 2 times 3 in multiple of prime number. 54 consists with a 2 times 3 times 3 times 3 in multiple of prime numbers. So you write 2, 2, 3 on the top, write 2, 3, 3, 3 on the bottom. When you reduce common numbers, 2 and 2 cancel out, 3 and 3 cancel out, you end up with a 1, 2s, and 2 3s, which end up with the 2 9s. So this is how you simplify the fractions. Now there are special cases. When special case with the zeros. So when you have zeros in a numerator and denominator, rather than doing anything else, you just reduce 1 0 on the top and 1 0 in the bottom. So you end up with 100 over 3 hundredths. And then you reduce another zeros on the top and zeros at the bottom, as long as they do have ones. You end up with a 10 out of 30. And then, again, you have a 0 on the top and 0 on the bottom, so you reduce them. You end up with 1/3. So, in other words, you can just reduce number of zeros, same number of zeros on the top with the same number of zeros on the bottom, and cancel them out. So again, 200 out of 300 can be reduced to 20 out of 30, and 20 out of 30 can be reduced as a 2/3. So that's with the zeros. Now, another special case is if one of them, either numerator or denominator, is a multiple of the other one, which means like 3 goes into 24 completely. Okay, then you can write it as a 3 times 1 and 3 times 8. And then you end up with a 1/8. Or another way is you can say 3 goes 3 once, 3 goes 28 8 times. So you end up with a 1/8. Same thing with the other way. You have 24 over 3. You can write this one as 3 times 3 in the bottom and 3 times 8 in the top, and 3 and 3 cancel out. And you end up with 8 over 1, which is 8. Or you can say 3 goes 3 once, 3 goes 8, 24 8 times. So you end up with 8 over 1. That 1 in a denominator, you don't have to write it anymore. You can just write the numerator. So end up with 8. So do some exercise. Simplify each fraction. Number 1 is 18 out of 48. So again, the way you simplify 18 out of 48 is write 18 in terms of factor tree. So even numbers is 2 times 9. 9 is 3 times 3. So you end up with a 2 and 3 and 3. 2 times 3 times 3. And 48 as even number. So you always have 2 as a common factor when you have even numbers. So 2 times 24. And 24 is again even number. So it's 2 times 12. 12 is again even numbers. 2 times 6. 6 again even number. 2 times 3. So that's it. So you end up with a 2 times 2 times 2 times 3. So 3 and 3 cancel out. 2 and 2 cancel out. You end up with a 1 3 on the top and 4 on the bottom. So you have 3/4. Okay. Now I'm going to try, that was number 1. I'm going to try number 3, 30 out of 42. When I do that, we can have a 30 as factor trees. So even number, you have 2 times 15 and 5 as 3 times 5. So this is 2 times 3 times 5. How about 42? 42, you have a 2 times even number again. So divide 42 by 2 is 21. And 21 is 3 times 7. So you end up with 3 times 7. So when you have this, you can cancel 3 and, 2 and 3 times 7. So 3 and 3 cancel out, 2 and 2 cancel out, you end up with a 5 over 7. So that's number 3. Okay. Now, this is the short video, but that's how you reduce a fraction so far. And then we will continue to the next video. I will talk to you soon. Good. Thank you very much, and be healthy and be safe.